You're sitting quietly, and then every neuron in your brain fires at the exact same time. All 86 billion of them. You don't feel smarter. Your jaw locks. Your fist close. Your back arches. And then darkness. You thought using more of your brain meant becoming more of yourself. That's what the movies told you. Lucy. Limitless. 100 stories about unlocking hidden human potential. They all got one thing deeply, scientifically wrong. The real danger of using 100% of your brain is not what you think. It's not about gaining too much power. It's about what happens when the most complex object in the known universe breaks its own rules. And here's the part that nobody talks about. It has already happened. You already use 100% of your brain. You just never use it all at once. Let's start with what your brain actually is. 3 pounds of tissue floating in fluid inside your skull. It contains approximately 86 billion neurons. Each neuron is like a tiny electrical wire that can fire a signal. Connecting those neurons are roughly 100 trillion synapses. That is more connections than there are stars in the Milky Way. Right now, as you watch this, parts of your brain are active. Your visual cortex is processing light and shapes. Your auditory cortex is processing sound and words. Your prefrontal cortex is evaluating meaning. But other regions are much quieter right now. The motor cortex is in standby. You're sitting still. The brain regions that handle physical navigation are resting. This is how a healthy brain works. Not everything on at once, but everything available when needed. But what if that changed? What if every single neuron fired simultaneously? Not taking turns. Not in careful sequences. All 86 billion, at the exact same moment, at maximum power. This is not a superpower. This is not the next stage of human evolution. What neuroscientists call this specific condition is hypersynchrony. And they already have a word for what it causes. A seizure. Not just any seizure. The most catastrophic version the human brain can produce. Let's walk through exactly what happens. Second by second. Neuron by neuron. From the first spark to the moment everything goes dark. And why the brain was never built to survive it. The moment begins with a cascade. One group of neurons fires. That signal travels to neighboring neurons. They fire too. And then their neighbors fire. It spreads like a wave of electricity across the entire brain. In a healthy brain, this spreading is normally blocked by inhibitory neurons. Inhibitory neurons are the brain's traffic controllers. Their entire job is to tell other neurons, stop. But here's the strange part. In our scenario, the inhibitory neurons are firing too. Everything is firing. Everything is on. And when everything tells everything else to go, nothing works. Your thoughts don't sharpen. Your vision doesn't expand. Instead, signals collide. The carefully organized timing of the brain falls apart. This is like trying to have 100 conversations in the same room, at the same time, at maximum volume. No single signal gets through. No message reaches its destination. The neurons that handle language lose coherence. The neurons that form memories can't record anything. The ones managing voluntary movement receive contradictory commands. And your body begins to respond. Not with genius. With chaos. Within the first seconds, your muscles receive conflicting signals from everywhere at once. Contract. Relax. Contract. Relax. Simultaneously. The result is rigid, involuntary contraction. Your jaw locks shut. Your hands curl into fists. Your back arches backward. This is not strength. This is you losing all voluntary control. The prefrontal cortex, the decision-making center of your brain, is overwhelmed. Not by too many ideas, but because the signals reaching it are pure noise, not information. At the same time, your brain is burning through energy at an extraordinary rate. Under normal conditions, your brain consumes about 20% of your body's total energy. It weighs only 2% of your body weight, but demands 20% of your energy. In this scenario, every neuron firing at once means energy demand spikes far beyond that. Your blood vessels rush to deliver glucose and oxygen to the brain, but the delivery system cannot keep up. Your neurons begin to experience metabolic stress. The chemical balance inside each cell starts to shift. Sodium floods in. Potassium floods out. The voltage inside each neuron swings wildly in the wrong direction. And heat begins to build. Not from outside your head. From inside. From 86 billion tiny fires, all burning at once. Let's talk about consciousness. Because this is where things get deeply strange. You might assume that more brain activity means more awareness. But consciousness, as neuroscientists understand it, requires order. Not more firing, more selective firing. The default mode network, the region that maintains your sense of self, needs contrast to work. It needs some neurons to be silent so that others can be meaningful. In our scenario, that contrast is gone. Every signal is equally loud, which means every signal is equally meaningless. Think about this. Imagine a photograph where every single pixel is set to maximum brightness. You don't see more. You see white. Total overstimulation. Consciousness doesn't expand. It flickers, and then it starts to go out. Based on what people report during complex partial seizures, the experience is often a strange, overwhelming déjà vu. A feeling that everything has happened before, or a sense that the world has become a stage, and you can see behind the curtain. Or a feeling of profound unreality, like reality is made of glass and you can see the cracks. But none of it is useful. None of it is the clarity of genius. It is the confusion of a system overloaded. And then the lights start to go out. Not metaphorically. The neurons have been firing so fast and so intensely that they begin to exhaust their energy reserves. This state is called the postictal phase, the aftermath of a seizure. The neurons that fired so ferociously simply stop. Not gradually. Together. And that is when you lose consciousness. When someone wakes up after a grand mal seizure, they remember nothing. Not because they forgot, but because no memories could form during the storm. Memory formation requires precise, ordered sequences of activation in the hippocampus. A specific pattern, like a fingerprint unique to each memory. In our 100% firing scenario, that pattern is pure noise. Nothing was encoded. Nothing was saved. You were not a genius during those seconds. You were not even present. Now let's think about your body. Because the brain controls everything in it. Heart rate, breathing, blood pressure, hormone release. When every neuron fires at once, every one of these systems receives contradictory commands. The autonomic nervous system, the part that runs your body without you thinking about it, goes haywire. Heart rate spikes and becomes irregular. Blood pressure surges beyond safe limits. Breathing becomes shallow and irregular. The risk of a dangerous cardiac arrhythmia climbs sharply. And the oxygen that neurons need desperately to survive may be cut off by a body in crisis. This is no longer just a brain event. It is a full-body emergency. And if the event continues long enough, something irreversible begins. Neurons that have been firing without rest begin to destroy themselves. This process is called excitotoxicity. When a neuron is overstimulated for too long, calcium floods in through the membrane. Too much calcium activates enzymes that begin breaking down the cell from the inside. The neuron essentially commits cellular suicide. And neurons, unlike most cells in your body, do not regenerate. When they die, they are gone. The brain that survives this event would have permanently fewer neurons than before. Where neurons die, scar tissue forms. Scar tissue in the brain doesn't fire signals. It acts as a wall. It blocks connections that once worked. In the aftermath, the very capabilities that make you human, memory, language, emotion, creativity, would be diminished. Not enhanced. Diminished. The irony is almost too profound to process. Trying to use your brain to its absolute maximum could leave you with permanently less brain than you started with. This is the hidden danger inside the fantasy. And if this happened to every human on Earth simultaneously, every doctor, every pilot, every engineer, unconscious, every person who maintains power grids, water systems, hospitals, gone in an instant. Human civilization doesn't evolve in that moment. It stops. And when people wake up, damaged and disoriented, the infrastructure is gone. The world would need to rebuild, with fewer capable minds than before. But here is where the story takes a different turn. Because there is one more layer to this. One more discovery that changes the question entirely. Neuroscience has uncovered something remarkable in the last 20 years. The brain is not limited by how many neurons fire. It is limited by how precisely they fire. The brain's real genius is something called sparse coding. When you see a face you love, only a tiny fraction of your neurons activate. When you solve a complex problem, the brain doesn't recruit more neurons. It recruits the right neurons. Efficiency, precision, selectivity. These are what intelligence actually looks like at the cellular level. And here is where the data gets fascinating. The most skilled chess grandmasters don't show more brain activity than beginners. They show LESS. Their brains have learned which neurons to suppress, which signals to ignore, which pathways to trust. This is called neural efficiency, and it is the opposite of what the 100% myth imagines. Think of a great orchestra. A symphony is not every musician playing every note at maximum volume simultaneously. It is precise timing. Contrast. Silence between the sounds. Your brain is that orchestra, and when every instrument plays at once, it is not music. It is noise. Here is a real comparison that makes this concrete. Patients with temporal lobe epilepsy sometimes experience what's called an aura before their seizure. A brief moment of strange clarity, déjà vu, or overwhelming sensory richness. For centuries, people misunderstood these moments as mystical experiences, prophetic visions, divine insight, moments of revelation. Some of history's most extraordinary thinkers, including possibly Dostoevsky and Caesar, may have experienced epileptic auras. But here is what those aura moments actually are. Too many neurons firing at once. Not a higher state of consciousness. A malfunction. And here is the deepest twist of all. The most intelligent humans who have ever lived did not use more of their brain. They used less of the wrong parts, and more of the right ones. Deep focused attention is, neurologically speaking, a narrowing process. When you are in a state of flow, creating, solving, building, irrelevant brain regions go quiet. The brain actively suppresses distraction to let the important signals shine. Intelligence is not about turning everything on. Intelligence is about turning the right things on and the right things off. That is what separates a genius from noise. So what would actually happen if humans used 100% of their brain? The same thing that happens when 100% of a city's traffic lights turn green at the same time. Total gridlock. Not faster movement. No movement at all. The fantasy of the 100% brain is seductive because it sounds like more is better. But the brain evolved for something far more elegant than brute force. It evolved to do more with less. To select. To filter. To ignore. To focus. To be brilliant not by overwhelming force, but by precision. We are already using 100% of our brains. Every region plays a role, just not all at once. The question was never, how do we use more of it? The question was always, how do we use what we have better? And that question might be the most important one the human species has ever asked. The answer is not in a pill, not in a scene from a movie. It is in sleep, in deep, sustained focus, in the challenge of learning something hard, in the silence between thoughts. Because the most powerful thing your brain can do is choose what not to think about. Drop a comment. What surprised you most about this? Subscribe to The Science, because there are a lot more impossible questions waiting to be asked.